Find the average value of DC voltage that can be obtained from the half-wave rectifier of figure, assuming that the diode is ideal one. So in this question, they have given us a half-wave rectifier and the input voltage is 200 volt and 50 Hz frequency. Output voltage, we need to find out DC output voltage, and the turns ratio is given, that is 10:1. So over here we can say that the primary input voltage is equal to 200 and the peak value of the primary voltage will be equal to √2 into 200 volt, which will be equal to 311 volt. So this is the peak value of primary voltage. Now we need to find out the peak value of secondary voltage, and after that we need to find out the DC average values. So first we will calculate the peak value of secondary voltage. So secondary voltage, for the secondary voltage we can use this formula, that is peak value of secondary voltage divided by peak value of primary voltage will be equal to number of turns in the secondary by number of turns in the primary. Formula for a transformer. From this, the peak value of secondary will be equal to Ns by Np into V0p will come. So Ns over here is 1, Np is 10 into V0p, that is 311 volt, which will be equal to 31.1 volt. So this is the peak value of secondary voltage. After this, we can find out the average value of DC, which is nothing but peak value secondary as divided by pi. So this we can write it as VDC is equal to the mean value of DC is equal to pi. 1 by pi will become 0.637 into the secondary voltage, that is 31.1. Once you do this, you will be getting it as 19.81 volt. This is the final answer.